In lesson 7, level creator, we disable the static game board. We're still using our animation input controller with one new component added for debugging purposes. The player still has the components the game board is disabled. Persistent game controller now loads the new scene, the current scene, level creator. And we have our layout creator, which has the layout data creator and the layout data controller scripts attached. So if I enable here, I try to mimic our old static level. Disable the game board. If I press a play button here, we see we're presented with pretty much the same thing. Now going into the scripts, this is the enable active input script. It's just a mono behavior that's added to our animation input controller that we can enable and disable input from the player. I'm going to start with the LayoutData Script. It's a scriptable object that contains all the nodes in the grid. We use a list, so it only needs to contain the active nodes. Lists are pretty easy to add and remove items from, instead of using an array and manually resizing. So we have the node count and get nodes. The choice of not returning the node layout data just made as another option, so we can do different things and employ different practices, and now and then, you know, one or the other may be the best choice. In this case, I never want to expose the nodes or access to the nodes outside of this class. I just figured, you know, it's been a long time since I saw get nodes or getter, so why not? So we return our nodes count, we return the nodes array, and we have something different here. This is called an indexer. Indexers allow you to access an array by passing in an index. The index could be any identifier that would identify the array. For instance, if I could have a dictionary backing here, and I could have used the key in my dictionary as the input parameter for my indexer. This signifies that it's from this class. So here we build our indexer. Just like a get, but we get to it's like a get and set property, but we get to define an index. It's pretty self-explanatory. So we check for out of bounds. In this case, I chose to throw an exception instead of Unity debug or something of that nature. That way, if any other, let's say, application or assembly was to, use this and they don't have access to the Unity engine, maybe they can handle the exception thrown in their own way. So just again, more choices. So we add a node, we remove a node, and we're doing these by position. Okay, it takes a node type, lazy initialization, find the index of that position. If we do have a node at that position, we don't add it. Else we create a new node, set its position and type, add it to the list. Return that we have added the node. And if we're removing the node, we do much the same. We find the index. If we did find an index in the array, we remove it and return that we did remove the node. Find node, takes a position. If the nodes array has not been initialized, it returns a default node. Default is a C# keyword that returns the default value for whatever type you pass in. So if it's a class, you probably get a null value as a return. A structure would give you, I guess, an empty struct of that type with the default value set, and so on and so forth. So if we do have nodes, we iterate through them and grab the one that matches the position. To find the node index, we do much the same, where we return the index instead of the node. And we can set a node that's already existing. Alright, so that's the layout node data. This is each node on the grid, each cell that would contain an entity for the level. Where to next? I guess we would go with see what the node is. And here we are. It's a serializable structure, 2 publicly accessible fields, the node type and the position. Node type, the enumeration of nodes. Now here we've defined what type of nodes we can use. Later on in these lessons, I use much the same to define the game state and show ways of how we can inject more game states in an already existing enumeration of game states. It's not injecting new game states, but it's using the game state and continuing on without having to create additions to the existing enumeration. Cool. So look forward to that. So now that we've seen what a node is and a node type is, let's see what should be the creator. Yeah. Let's go into the node creator. Node creator is a mono behavior. Box collider defines the bounds of our level. We have a nested class to define some colors. Saw those in the inspector. The layout data that we're using, remember that's a scriptable object that we can save as an asset in Unity's asset directory. And we have our access field to our node type colors, excuse me. Fold out we use in the editor script to show or hide the nodes list. We'll get to that. Reset is called in the editor, and or believe when the script is first added as a component to the game object. And here we can get a color for each of our nodes by passing in the type. Okay, from the creator we go to the layout data controller. Controls the creation and preparation of the game board. Now this inherits from the layout controller, which we should attend to first, which defines also a nested class of what type of prefabs to use to generate each node. Okay, and now we have a list of those prefabs that we're going to be creating. The layout data reference that we're going to use to position and type each node. And here we go. So in start, this is the base class, implements LayoutController. This is an interface we define. We'll get, we should just get right into that. F12 on would get you to that definition. So here's the interface we define for LayoutController. It needs a layout data type getter and two methods. So that's our contract. So we were here, we define a virtual start that calls make level from layout data, give it the layout data in the parent transform, and then we enable the nodes. To make layout from data function, the definition in the base class should suffice for all the inherited classes. I think that's what I did. We'll see why the base class was created later. So we take the layout data and we go through the prefabs. We find the one that matches the layout type, and we use that prefab. Then we create, we'll get into that, create the node, and we set its parent to the parent transform that we passed in. Enabling the layout node is pretty much the same. Setting the parent transform to the parent that's passed in gives us this ability. We can get the child of that parent now, and we have access directly to that node, so we can activate each in turn. Creating a node takes the node and the prefab, creates a name for our node, make sure we have a prefab to use, then we initialize the node, instantiate the node, as type game object, does the casting, sets the name, position, activates. Set the game object activation to false, sets active to false, returns the node. So now we've created a node and disabled it. Activate the node, checks to see if it's a spawn point. If the node is a spawn point, then it would get the player and set the spawn point wire limit spawn point to that transform. That's why we no longer need to set the spawn point in the inspector. And actually we don't even have an option to, because it's generated at runtime. So then we set the active state to true. So that's how the controller handles the created data to display at runtime. now we have the layout data controller that it inherits from our layout controller that's used to display the data in the creation level where we can create and test right away. So on awake, we're gonna get the component that's attached, our layout data creator, and we're going to get the layout data from that and assign it to our base layout data. That's why I sometimes prefer to do that explicitly. That way, at that time I wouldn't stumble because you can see it. You know, it's in the base class. Okay, now that we've got a layout data controller, we went over the base controller, we did the creator. What's left to do is see how it's all drawn in the inspector. First, we have the layout data creator editor. Now, let me close all of these down. So, custom editor of type layout data creator, of course, and define some static strings here for the property names, some messages and labels, and the properties we're going to access, serialized properties I should say. Here we find the properties on that object. We set our target to the type of object that's coming in, where we have access to it throughout the script. We get the collider that was mentioned as the bounds of the box, and we create a layout data editor. Now before I move on, I'm gonna go to the layout data editor. Now remember, the layout data editor is that scriptable object that contains the list of the nodes that generates the level. Okay, so in that instance, it's a scriptable object and it's stored as an asset. We can also define how that's drawn. Define pretty much how any object is drawn in Unity's editor. So we take advantage of that. Here we have our constants to define sizes, properties, and labels. We have a reorderable list of our nodes. We provide access to the internal API to our layout data and the list that we're going to generate. We do a lazy initialization of the nodes list. We set the callbacks in that initialization. And on enable, we just convert the target to the actual type of object that we're going to be accessing. Private set, internal get. Again, assembly access only. Then we draw the list. Serialize update and apply. The list is between those, so you can pull the values from the serialized object and apply it on changes. Here's our callback for drawing an element in that list. And it's used here, setting the callback. So we get each element at the current index. Define a size and padding for our rectangle. We set the first rectangle, give it a Y spacing. That's to move it down just a tad. They are not centered along the list, so it's offset when you select it and looks like it's a little not centered, so we do that here. get a position, set the positions, and we show our vector 2 in this case. We show vector 2 because it's a 2D and we build on a 2D surface. So we come here and so we target that so we can build on a 2D surface and get accurate mouse to screen positioning. So we display our positions in 2D. Then we set it as a 3D position back to our node. The type of node setting, we define that here also. We get the relative property of the node type. Set some positioning, and we display that property. Now this function or method, if it doesn't return a type, I'm assuming, takes a parameter to get the color of that node. And that was defined in the data creator class, I believe. Yeah, so here's the node colors and get node color. It's a function, takes a node type, returns the color. So in our layout data editor, in our draw layout nodes scene GUI, we take a delegate that accepts a node type and returns a color. So here we never forget, if we are going to change the color or values of any defined static members in the editor, we're going to save what it was so we can set it back. We get all the count of the layout nodes, set a color gray, that's as a default color. Then here we call the get node color delegate and we invoke the node type. That would give us the color to which is set in this method here. We fade the alpha just a bit. Get another handle color. Okay, why am I doing this twice? That's a default in case something comes which is not necessary. We'll remove that. Okay, now we draw a button, a scene handles button that we can click on at the node position, no rotation, or guess that's no rotation. We have the sizes and the pick size and what type of I guess object we're gonna draw. So there's different kinds. Cube seemed appropriate. If the button was clicked on in the scene, if it is the selected, already selected node, we're going to record some action for undoing. We're going to set, and then we're going to change the node type. Now this convoluted little, I guess, formula here, it just gets the node type, current node type, which is from 0 to the last node type in the enum, adds 1 to it, and then uses the length of that node, that enumeration. Let me take this away, to wrap the value. So every time we click, it'll just keep changing the enumeration until it gets back to the first one, and so on and so forth. And then we set our node index to what we've currently clicked on. Editor utils, we set two dirty targets. This is so the inspector could be updated. The layout data that we're changing and the target. They're different. The target is the... Wait a minute. They're the same right now. I pulled this class, this method outside from this one. So before they were different, because one was a layout data creator and one was a layout data. Now they're the same, so we don't need both calls. Can just use one. Cool. So now we show the selected node. We show a circle over or in the square. That way we know what we're working on right now. We invoke our getColor method so we can know what color to color our circle. And then we reset our handle. When we're adding and removing a node, we do so if the current event shift means if we're holding down the shift key, either shift key, left or right. We find the index at that grid position. And grid position will pass in. We'll get to that method here in the layout data creator editor. Too many mouthfuls. I gotta write shorter names. We draw a button. And if we click on it, if there is no node there, we are going to be adding a node. So we record that there was no node. We add the node, and we set the node index. If there is a node, we record that there is a node and that we will be removing it for undo. We remove that node, and we set the current selected index to none or -1. Then we make sure to set dirty our target or our layout data for update in the inspector. We get another color and we set a cube cap at that position. This is a little box around where we're holding down the shift key for indication. Draw current label is the pop-up that shows the type of that grid section and its X and Y position. So we get the grid position we're at and we align it. We set a style for our GUI label, do some more alignment and height, and then we draw a label in the scene using handles label. The label style we use, and the node type and string format takes care of the rest. Okay, now in our layout data creator, we stopped code here. And this method creates an editor from the layout data editor that already exists. So we set a temp editor, and if we do have a selection, we do have some data, a scriptable object, and it's not null, then we'll create a new editor to display that in our present inspector. So we set the temp editor, we destroy the current editor if there was one. We use destroy immediate here because this is editor stuff, it's not runtime. And we destroy that editor if it was set. And then we set our new editor that we just created to our editor that we're using throughout our code. So that takes care of these two functions. Creating an editor for use in any other inspector component. So now after we've created our editor in our unenable, we set a callback for updates, and we remove ourselves from the static callback on disable. Also, we take the opportunity to destroy a reference to our editor that we've created. In our inspector, we get the see if we have a scene view selected. There's a scene view and it's active. If it's not in 2D mode, we draw a button in a little help box to say, hey, click here. This works better in 2D mode. The calculations for positioning the mouse and the nodes don't work very well in 3D mode. So we can just have a button and set that from here. Then we call update on our object so we can pull the property values out. And this call here, begin check change, is going to check these properties between the begin and end check change. And if has been a modification, it's going to invoke whatever in this condition. So if there has been a check change, we check to see if we need to create a new data. That way we can add new data and have our editor update by adding a new scriptable object of our asset, our level asset, and have it displayed properly. So if we do have a scriptable object, our level data, in the slot, and we have successfully created the data editor, in a fold out, we display its inspector. Right? And now, if there is not one selected, we give an option to create a brand new asset from scratch. That involves getting the type that we want to create, the path that we want to create it in. This is a pop-up panel. You click the button, a panel pops up. Where do you want to save the file? If we did provide a valid path, we create an instance of a scriptable object type of our layout data. We create that asset. We save the assets. We refresh so we can see it in the project panel. We set the current reference of that asset we just created to our property, and then we create an editor to display it. Changes were made, we push them back to the serialized object. We have 1, 2, 3 more methods here. Mouse to grid position gets in the scene view, the current mouse position, the camera, and converts the mouse position into grid position. So we can know what cell or node our mouse is over. Update. If we do have a scene view selected, then we'll repaint it so we can see changes made in the inspector reflect right away into the scene view. And our on-scene GUI. If we do have a scriptable object selected, we call this handles utility call to stop the object from being unselected. If we click in the scene and we don't happen to click on a button, and you click somewhere off the object in the scene, it would usually select nothing in the hierarchy. This call would prevent that from happening. So as we're creating the level, selecting an empty space in the scene view won't deselect our object from the hierarchy, and we can continue to work. Then we call in our level data editor that draws the nodes in the scene. We give it pass in our action, our function, which is the delegate that defines what color we're going to be using for that type. We get the grid position. We see if the collider, that's the box collider that defines the size of our level, if it contains the grid position where our mouse is at that moment. And then and only then do we allow for adding and removing of nodes and drawing that label that defines the node that we're currently hovering over. Let's get our solution back up front. Now this is just a simple drawer that draws any type that defines that's this type of node prefab. And if you remember, that's just whatever prefab that we want to use to draw for that node type in our level. So a quick little drawer. Instead of drawing the regular array, it would, just easier to deal with this way. At least easier to look at, I'm assuming. Well, for me, we get the node type property, and we get the prefab property from the relative property values of what's passed in. So by now, I'm hoping you're familiar with this. So we define a rec for the node type. That's would be an enumeration, a drop down, and we define a rec for our object type, and we draw the properties, and we let Unity decide how they're going to be drawn. Okay, so I think we've been over all the scripts. If there are any questions, now's the time to ask them in the comments, which I haven't received much of. But I know this was fast, and it's a lot of scripts, and help may be needed. Okay, so here's our level, our board. So if I select this, it shows right away. That's because of the update that we registered. Okay, so I select, and I can change. Undo, Control and Z, Control and Z, Control and Y, redo. So we have all the functionality, and I guess we can change the one he's under. And can we add one here? Let's add a wall here, and that's a spawn point. Let's make it a pushable cube. So if we hit play, our level's been modified. And of course, we can modify it any way we want. We can add a few more walls here, maybe a pickup here. Alright, and we could move around, and it's our game. Okay, so here we have our colors. We can change the color of our wall. Say our spawn point, we want that to be yellow, and we can undo it all. We define what types and what prefab to use for each. Cool. So that is our level creator. This was a long level. I'm not going to play it out, but I will go to the level controller. We can save that and describe what we're going to be doing next. So in lesson 8, we're going to take the level we just created with more that I have here in the background, and we're going to make it into a playable level where they switch between levels when you clear all the pickups.